So dot product is actually really, really easy. Dot product is really easy. Okay. But the reason why we need to understand the dot product is because it's baked into this formula up here. Okay. So let's come back a step. Let's take u and v just like before. Let's take u and v just like before. So u is equal to 7,5 and v is equal to 3,2. And let's suppose now I want to find the angle between these two vectors. Okay, so let's say that this is u and this is v. Let's suppose I want to find the angle between those two vectors. So let's see how it works in the formula. Would you be happy that I need three things before I can calculate this? I need a dot b. Well, in this case, I just need u dot v. I need the modulus of a, or the modulus of u in this case. I need the modulus of b, or the modulus of v in this case. I have the dot product bit. I have the numerator of this formula. Okay? I just now need the denominator. I need the lengths of each of these vectors. So I need the length of u, and I need the length of v. Could you help me calculate those? So how would I calculate the length of u? Good, it's just Pythagoras, right? So what would it be? Be square root of 7 squared, good, plus 5 squared, good. So okay, leave it in surd form, so leave it in square root form. So square of 7 is 49, square of 5 is 25. If you add them together, you get 74. So let's have a go at v then. What would the length of v be? So it'd be the square root of plus 2 squared. So u was 7 squared plus 5 squared square rooted, which makes square root of 74. Okay. V, length of v would be 3 squared plus 2 squared square rooted, which is not quite actually. Square root of 14, isn't it? So square root of 13. Yeah, square root of 13. Okay, so now I've got all the pieces of my puzzle to put into the formula. Okay, so I've got cos theta. My formula tells me that I've got cos theta should be equal to the dot product of these two vectors, which we just said was 31, divided by the length of u, which is square root of 74, times by the length of v, which is square root of 13. Okay, so you stick all that in your calculator, press cos inverse, then you'll find your angle. It is 1.8, do we agree? All right, okay, let's just have a go at another example. Let's try and find the angle between these two vectors here. So I've given you three-dimensional vectors. U is 714 and V is 860. I'm after the angle between these two vectors. So according to my formula, I need three things. I need my dot product, I need my length of my first vector, and I need the length of the second vector. So let's just work it through first of all. What I do first is I get all the pieces of the puzzle in place, then I put it all together in the formula at the end. Okay? So let's do the dot product bit first, because I think that's the easiest bit. So we go u dot v. So u dot v tells me that I should just multiply corresponding elements together. So 7 times 8, 1 times 6, and 4 times 0. And then I should add them. That's what the dot product means. Okay? So 7 times 8 is 56, 1 times 6 is 6, 4 times 0 is 0, which means that this is 62, right? Now I need the length of u. I need the length of each of my vectors. So okay, let's do length of u first. So length of u will be 7 squared plus 1 squared plus 4 squared square rooted. What does this come out as? 49 plus 1 is 50, plus 16 makes square root of 66. Okay, good. And square root of v is equal to, the length of v is equal to 8 squared plus 6 squared plus 0 squared square rooted, which is square root of 100 or just 10. Yeah? Okay, fine. So now I've got all the pieces of my puzzle. I just need to put them in my formula and it should fall out nicely. So I've got cos theta is equal to a dot b, so the dot product of my two vectors, which is 62, divided by the product of the length of my vectors. So that multiplied by that. Okay? And actually we can stick all of this in our calculator, press cos inverse, answer, and see what it comes out as. And it should give us our angle. Okay? So 40.3 degrees. 40.3 degrees. Okay?